All right, now we're going to do the Unit 5A practice test, Part 2. All right, so for number 8, it says plot the points from the table. Label each point on the graph. Okay, so we have table number 1 and we have table number 2. My best piece of advice for this problem would be to take your two tables and create a set of ordered pairs. So from table number 1, I have 4, 2, 6, 3, 8, 4, and 10, 5. And then for table 2, I have negative 4, negative 10, negative 2, negative 6, 0, negative 2, and 2, 2. Okay, so the first thing I would do would be to rewrite those as ordered pairs because we're going to need to graph them. Okay, so I have my coordinate plane on this slide. So table number 1 I'm going to do in red. So double check that you are plotting everything at the right points. This is 4, 2. Then I'll plot 6, 3. Then I will plot 8, 4. And then I'll plot 10, 5. Okay? And when I connect these 2 points, when I connect these 4 points, they make a line. I'm going to, and I'll label this number 1. Let me get a different color for table 2. Okay, for table 2, I have negative 4, negative 10. Now it's going to be really easy to make a mistake on this if you're not careful. So just double check yourself that you're plotting everything in the right spot. So negative 4, negative 10, negative 2, negative 6, 0, negative 2, and then 2, 2. Okay. One way you can double check yourself is if you end up having a point over here off to the side and your line does that, a line was not going to crink or have a bend. It's going to be perfectly straight. And when I say straight, I don't mean vertical and horizontal. I mean you could take a ruler and create a straight line. All right, so here are my two lines. It says, which table has a greater rate of change? Explain how you know. Okay, so it's kind of hard to tell right here. They're going in the same direction. They're both going up from left to right. It might be hard to see which is more steep than the other. So what we can do is we can extend our lines. If we take a look, when I plotted my points, I created a pattern. Remember, if you finding the slope, it gives you a pattern. My rise was 4, my run was 2. Rise 4, run 2, rise 4, run 2. So I can use that pattern, and I know that for my next point, I can go up 4 and over 2, and there's another point. Up 4, over 2, there's another point. Okay, get my red back. So for my red, I went down 1 to the left 1, 2. Down 1 to the left 2, down 1 to the left 2. So if I go down 1 and to the left 2, I can extend this line. Okay. All right, so now it's a little bit easier. Because they cross, it's a little easier to tell the answer to our question here. So which table has the greater rate of change? A couple things that you can think about. When they say greater rate of change, they're also asking which is steeper. Okay, that's the same question. Okay, what's going to happen, if you remember from that activity 1, the graphing calculator activity, the steeper the line, the larger the number was for the slope. So the absolute value of m will be larger. The reason I said absolute value is because if we had negative m's, which if you look at the digit, so finding the absolute value, the bigger number has the steeper slope. But if you take a look here, line number 2 is going to be steeper or have a greater rate of change. Okay, so for number 1, if we look at our rate of change for number 1, we went down 1, backwards 2. So my rise over run would be a negative 1 over negative 2, which becomes 1/2. And then if I use blue for my table number 2, if I look at my rate of change, I went up 4 over 2, which simplifies to 2. So my rate of change for number 1 is 1/2. My rate of change for number 2 is 2. So number 2 is my greater rate of change. Now on this problem, you did not have to do both. You could have decided that table number 2 has the greater rate of change because the line was steeper, and that would be your explanation. So if you looked at the steepness of the line to determine the answer, that's your explanation. If you want to look at the numbers and find the slope of each and use the slope to determine which has the greater rate of change, you would explain that. So again, there's 2 different ways you could have done this. If I want to use the slope, that this table number 2 has a slope of 2, then I would say table 2 has a greater rate of change. I know this because the slope is larger. Okay? Or you would say table 2 has the greater rate of change because the line is steeper than number 1. You don't have to do both, you could pick one. Which relationship is proportional? Explain why. So, if a reminder for proportional, a couple things have to happen. Well, actually, the largest thing has to happen is the line passes through the origin, which is 0, 0. So a couple ways you could do this. I can see visually which number passes through the origin. Number 1. Okay. Another thing you could do is the origin is 0, 0. So if you're given a table and you notice that the table has 0, 0 as an ordered pair, then you know that's good to go. But we looked at the graph. Number 1 goes through the origin. It doesn't go through the origin based on the points that are given. You have to extend that line. So something to keep in mind that's important is just because the points you're given doesn't have the line going through the origin, if you were to extend it, it would. So be very, very careful on a problem like that. Okay? Just because they give you a set of points doesn't mean those are the only points possible. It can be extended in either direction, so be careful. Okay, number 9. Number 9 and 10 are both using the information that you see in the white boxes. So number 9 says, which function or functions are proportional relationships? Okay, so this could be more than one. Okay, so it could be more than one. Now it's very hard, sometimes it's hard to see when everything is in different, presented in different methods. If you had all tables, it might be easier. If you had all graphs, it might be easier. So for some of you to do this, you may need to take function number 1 and graph it. Take function number 2 and graph it. You might not. It's up to you. So to look, if we're looking at a table, to figure out if it's proportionate, I want to say, is 0, 0 a possible solution? So if you're given a table of values, you want to see is 0, 0 a possible solution, because what that means is the line goes through the origin. If the line has 0, 0 as an option or as an ordered pair, that means the line goes through the origin. Do you see this right here? This is an ordered pair of 0, 2. That's not 0, 0. Because of that point right there, function 1 is a no. Function number 2. Okay, and I'm going to use different colors for you here. So for function number 2, when you're given an equation, if it's in the form y equals mx, is always proportional. Okay, so if it's in the form of y equals mx, it's always going to be proportional. It's always going to go through the origin. Okay, this equation in function 2 is in y equals mx form. The m is -3. So this is a yes. Okay, so function 2 is a yes. Function 1 is a big ol' no. Okay, function 3. If the line goes through the origin, so passes through the origin. So function 3 is a yes. So your answer would be B and C. Number 10, which function has a greater slope? Okay, so we can find the slope from any of the methods that you see here. So for function 1, let me get my red back since that's what I did on the last one. So for function 1, so function number 1, I'm going to take 2 points. I'm going to do my slope formula, y2 minus y1 over x2 minus x1. So pick 2 points, doesn't make a difference. y2 minus y1 would be negative 2 minus 2. x2 minus x1, so these are going to be my x2, y2, x1, y1, just so you can kind of keep track of what I'm doing. So y2 minus y1, x2 minus x1. I'm going to add the opposite here, just to make life easier. I'm just going to do it on all of them, even though there's a 0. And I get negative 2 plus negative 2 is negative 4. 1 plus, there's no negative 0, so just 1 plus 0 is 1. So my slope for the first one is negative 4. Okay? Function number 2. When you're given an equation, that number multiplied by the x is the m, which is the slope. So in this case, we have negative 3. Okay? And then for function number 4, I'm going to use my rise and my run. So I'm going to pick 2 points where my line crosses the grid lines perfectly. Okay? And I'm going to rise and run. My rise is negative 2. My run is 1. So my slope will be negative 2. Oops. My slope will be negative 2 over 1. Which equals negative 2. Okay? Now, when it's asking which is greater, it's easy if your numbers are positive. But if the numbers are negative, which has the larger absolute value? And absolute value is distance from 0. Okay? So which of these numbers, negative 4, negative 3, or negative 2, has a larger absolute value or larger distance from 0? Function number 1. Negative 4 is going to give us a steeper line. A steeper line means it has a greater slope. Don't be fooled by that one. Be very, very careful. 11. You walk at a pace of 3 miles per hour. Which line best represents this scenario? So 3 miles per 1 hour. So this means my change in y is 3, and my change in x is 1. Or, let's take a look at this again. My rise is 3, my run is 1. So what I'm going to do is I'm going to pick some points that cross through the ordered pairs or the grid lines perfectly, and I'm going to see which one has 3 miles per hour. My first one, I rise 3, I run 1. Oh, that looks promising. I'm going to check each of them just in case there's some sort of secondary piece of information I'm missing. B is 1 by 1. My slope would be, or my rate is 1 over 1. B is out. C, I rise 1 and I run 3. Nope, I want 3 rise and run 1. So C is out. And then D's kind of crazy. My rise is 1, my run is 10. So that's out. Okay, so for this problem, you could go through and you can find the rise and the run. You can find the slope of each line and see which one is 3 miles per hour. Okay, remember, anytime you see per, this means division or fraction. So 3 per 1 hour. Okay, so keep that in mind. Now, if If you didn't like using the slope for this, an alternative option, so let me erase my notes here. So we did end up getting A, by the way. But I'm going to show you an alternative way to figure this out. You walk at a pace of 3 miles per hour. I could have looked at my time, said 1 hour, and looked at my distance and said 3 miles. And figured out which line has me going 3 miles at the 1 hour mark. Here's 1 hour, in between 0 and 2. Okay, D, I can't even tell where I'm at. C, I'm not even at a full hour. Okay, so here's, excuse me, these are miles. That's 1 mile, 2 miles. Here's 3 miles. Okay, so at the 3 mile mark, right here, which of my lines have I been going for an hour? So I could actually take this and kind of find where, kind of battleship style, I could see where 1 hour and 3 miles match up, and it's right here on A. So that's an alternative way to figure this out. All right. Number 12. A local rent-a-car company charges $150 per week for a small car. So $150 per 1 week. Choose a graph from the right, now ours is below in this example here, that displays a rent-a-car company whose weekly rate is less. So I want less than $150 per week. Okay, so I'm going to look at the 1 week mark. Company A is above 150. So that's out. Okay, let's look at B. At 1 week, that's at 200. They're out. Look at C. At 1 week, I don't know what this is, but it's less than 150, that's for sure. Okay, if you look at my 150. 150. So again, like I did on the last one, I could find where one week meets 150 on each of these if I wanted to, and see where the line goes. Okay, D is exactly 150, and that is out because we wanted less than. Okay, so C is our final answer. C is the only one that shows less than 150. Number 13. Which boy had the fastest race time? Okay, a note about this problem. It is easiest to compare if both are written or shown the same way. This is what I mean. For Carlos, I'm given an equation. For John, I'm given a graph. It would be easier to figure out which has the fastest race time if we either made them both equations, we made them both graphs. It's hard to compare when we have an equation for one and a graph for the other. They're not written the same, okay? It would be like trying to compare, you know, if we're looking at like fashion. You have two guys, you want to see who's dressed better. Well, one's in a suit and one is in casual clothes. Well, it's hard to tell who looks better if they're in two different types of clothing. If they were both in dressed up clothes, it'd be easier to tell. Or if they were both casual, it'd be easier to tell. But if one's dressy and one's casual, it's hard to compare the two to each other. Okay, so if we can get them both on the graph, that would be helpful. Now, something else to think about. Let me change my color here. Something else to think about is our unit rate. Okay, you could also find the unit rate for each. Okay, so to do that, my unit rate for Carlos is 1/6. That means 1 minute for 6 miles. Okay. Now over here, at 1 minute, I can't tell how many miles. So that's a little bit of a problem. 1/6, I can't even visualize what 1/6 is decimal-wise to know which would be greater. So again, if the unit rate is a decimal or a fraction, a little bit trickier, okay? But not all is lost. I can still take this unit rate and I can determine something. If my unit rate is 1 minute, oops, hold on. If it's 1 minute, I go 1/6 of a mile, okay? What if I adjusted this? Okay, so my x is my number of minutes. What if I made my x become a 6? And I said 6 minutes. If it's 6 minutes, that means I went 1 mile. So if in 1 minute I went 1/6 of a mile, in 6 minutes I would go a whole mile. So I could look over at 6 minutes on my graph here, and I would see that he went 1 mile in 6 minutes. Okay, so if Carlos goes 1 minute or 1 mile in 6 minutes, and John goes 1 mile in 6 minutes, they are the same. Now I do understand that was a little bit trickier what I just did, trying to figure out a way to match them up. Another way you could have looked at it, if you wanted to compare unit rates, was you could have said, okay, well, if I'm going to find an ordered pair, okay, and I'm going to find my rise and run and compare them. So my rise would be 1, my run would be 6. So that makes my slope 1/6. Do you see how both slopes are 1/6? That means they are the same. Okay. If I wanted to, let's look at what I did in red. In red, I said, well, just compare the two. Okay, well, if I tried to graph that equation, y equals 1/6x, if I made a table, pick an x, get a y. Well, my x is 0. If my x was 0, I'd have 1/6 times 0, which equals 0. Plot 0, 0. If x is 1, I would say 1/6 times 1 equals 1/6. I have no idea how to plot that, so I'm actually going to pick a number that I know will create a whole number. The only thing times 1/6 that will create a whole number that's next would be a 6. 1/6 times 6 equals 1. So I'd go over 6 up 1, and I'd notice that as I'm plotting my points, they're the same points, which mean I have the same line. Okay. To be honest, I think your best bet is going to be, so your best option here is going to be find the slope of each. What's nice about this is the slope of Carlos is given in the equation, and the slope for the other is pretty simple because these plot points are pretty easy to get, 1/6. Okay, so our answer is C, they are the same. Okay, sorry about that. We had to duplicate slides. Number 14. The table shows the volume of water released by Davis Dam at Lake Mojave over a certain period of time. The amount of water released by Parker Dam at Lake Havasu is shown in the graph. So again, we have a situation like we had on the other where we're showing two different illustrations. We have a table, we have a graph. So you have a couple options. You can either create a table for Parker Dam, or you can take Davis and you can graph it. Okay, those are probably two pretty decent options. The other option you have, like what we ended up doing with the last one, is I could. My other option would be to find the slope of each. Okay, because what we're looking for here, which dam has a greater water release average? So basically, I'm trying to find greater slope. Okay, so which has a greater slope, or a greater unit rate, or a greater unit rate of change? Explain your reasoning. Okay, so we have two situations. We either have Parker Dam, and then we have to choose what their rate is, or Davis Dam, and then choose the rate. So we're going to do this both ways. I'm in the blue. I'm going to go ahead and I'm going to graph I'm going to graph Davis Dam. And when I try that, take a look at here for a second. 2.5 and 32,500. To be completely honest, especially with this being so small, this is going to be difficult, okay? It's going to be somewhere around here. I don't even know for sure. This you have to be very careful of, because if I'm off by a little bit, that's going to be a problem. But let's see. So 3 is 39. It's, especially with this, it's really, really hard to get a good line. I can't even tell you if this is for sure what's going to happen, what it's going to look like. An option that I have is I can graph these two, their whole numbers, and hope that I get a better read here. Let's see if it lets me zoom. So 3 and 39,000. So it would be right about here. We know it's going to start at 0, 0 because if we have no time, it's no water. And then I'm going to graph 6 and 78,000. So each of my tick marks on the left are 10,000. So 6 and 78,000. That's going to be somewhere about here. Okay. All right. So this is my line for Davis. And the black one is my line for Parker. So from the graph, I can tell that Davis has a faster water release. Okay, my slope, oops. Sorry about that. Oh, I lost it. Let me back this up again. Okay, we're going to pretend my line's right about there. Okay, so this is Davis, and this is Parker. Okay, so I can tell because my line is steeper, Davis has the faster water release rate. Okay, so it's either going to be C or it's going to be D. So A is out, B is out. Now we need to decide what's the rate. Is it 7,000 cubic feet? Is it 13,000 cubic feet? That is saying for 1 second. So at 1 second, how much is it? Now if we just look and I zoom in here, if I zoom in at 1 second, okay, so focus on that area. At 1 second, it's somewhere, if I look at my lines here, my first line is 10,000, okay? This point right here is going to be above 10,000, which would lead me to believe that this 1,300 cubic feet is my answer. But I don't know for sure. To be honest, my graphing is not perfect on this but this grid is so tiny, so I'm not going to depend on my perfection here. What I'm going to do is I'm going to take a look, and I'm going to take these two pieces of information, and I'm going to put them in the slope formula. So that's the y2 minus y1 over x2 minus x1. So I'm going to say 78,000 minus 39,000 over 6 minus 3. Remember, I took the first one of my x's and of my y minus my second y. First x minus my second x. Okay? All right. Okay. So 78,000 minus 39,000 is 39,000. 6 minus 3 is 3. When I simplify that down, I end up with 13,000, which is D. That is correct. All right, that is all for this practice test. Next up is that green packet. Make sure that you watch the videos to help you with the examples on those.